Alright guys, welcome back. Today is our final lesson with probability. I included this section because I thought it's a good visual to see why we add or subtract when it comes to mutually exclusive events. And I think it's a good final lesson for our unit here. Okay, so I have this uploaded for you on Google Classroom. Please make sure that you look at it. We're going to go through this, and it shouldn't take too long. So here we go. Venn diagrams. Okay. Problem 1. 400 college students. Out of 400, 120 are enrolled in math, 220 are enrolled in English, 55 are enrolled in both. Okay. So let's interpret the Venn diagram first. So in this bubble right here, we have all the math people. And in this bubble, we have all the English. And then what they both share, what's in common, is 55. Now, what you might say is, well, Mr. McCullough, they said 120 are enrolled in math. I only see 65. Well, remember, 55 are enrolled in both of them. That number's included. So I have to take that out of it. So as you can read, 65 are just math people. 165 are just English people. And then 55 is both. So if I add these two numbers, I get 120. If I add these two numbers, I get 220. So it does work. Now, the 115 that's on the outside are people that didn't choose to be a math major or an English major. Okay? So that's what the 115 outside stands for. If you add up all three numbers, you get 400. Okay? So that's just a quick overview as to how to read this Venn diagram. So let's look at part A. What is the probability that they enrolled in mathematics? Okay? Now, just like normal probability, the total is going to be on the bottom. There's a total of 400 students here. And if you're not sure, look back. It tells you. Or add up all the numbers. And out of 400, how many of them chose math? Well, I don't even need the Venn diagram for this one. There was 120. Okay, that enrolled in mathematics. So let's say they didn't give you this. You can still add these two up. I know these 55 did both English and math, but they're included, right? They did math. Okay, so we get 0.3, or 30% as our answer for that guy. Okay. Part B, the probability that they enrolled in math and English. Okay, what are the odds of that happening? Well, let's take a look. How many math and English people are there? Well, they kind of tell us in the problem. It will be, what, 55? Okay, math and English, there's 55 of them out of a total of 400. Okay. So far, hopefully you're kind of getting the grasp of this, reading the Venn diagram a little bit here. Okay. So let's go ahead and do part C, the probability of math or English, not both. Okay. What's that going to look like? Well, let's see. I know there's a total of 400 students I got to take into account. I don't want these 55 of them, though, right? They took both of them, so that number's out. So the Venn diagram is needed for this. How many just chose mathematics? 65. How many just chose English? 165. Okay, so I'm going to add those. Now the other key word here is or. Okay, or is a good way of knowing that you're going to have some addition involved. And the reason for that is I'm asking the odds of me selecting a math person or an English. So when I randomly pick a person out of this college, I want more in that sample space. Okay, so it makes sense that I'm adding more in the numerator out of a total of 400 students. Okay, so the Venn diagram helps with this. If not, we would have to figure out individually how many students are in each one of these before we actually, do the addition and then divide. Okay? So this would be what, 230 out of 400, which is 57.5%, or if you left it as a decimal, okay, either way. So that would be part C. Here's our first problem with Venn diagrams. All right, so far so good. Let's continue. Let's see if I can't zoom in a little bit further. Makes it easier there. Next problem. In a group of 35 children, 10 have blonde hair, 14 have brown eyes, 4 have both blonde hair and brown eyes. So here's my Venn diagram. I use BL and BR. You could use any label you want. So what I did is I know 4 of them have both of these. In this bubble, okay, blonde hair people, I have 10 total. So if 4 have both of these features, then this must be 6, right? Because combined gives me 10. And then over here, if I combine these two, I get 14, which is what it said here. There's 14 students who have brown eyes. And then the 15 on the outside just means that they have neither. Okay, they're not part of this character trait or whatever you look. I can't talk today. Or however you want to state it. So total's 35. So if I add these up, I get 35. Okay, and you can always check. 6 and 4 is 10. 10 is 20. Plus 15 is 35. Okay. So if you want to try this on your own, pause the video. See if we get the same answers. Okay, part A. Find the probability that the child has blonde hair. Now notice, it didn't say only blonde hair, right? It just said blonde hair in general. So, let's write this down. Probability that you have blonde hair. Okay, there's a total of 35 that goes in the bottom. And then we have what, 10? 10 people that have blonde hair. Some of them could have brown eyes. That could be included. There's no big deal for this. Okay? So divide those, and this is what we get as a decimal. So far, so good. Next, part B. The probability that a child has blonde hair and brown eyes. The probability of brown hair and brown eyes. Okay, so there's an and involved, so we want both of those to occur. So looking at the Venn diagram, I think we only have one option, right? There's one number that satisfies that. So it's going to be a 4 out of a total of 35. Both of those occur. Okay? Divide. We get that as a decimal, or 11.4%, either way. Last one, part C. The probability that you have blonde hair or brown eyes, not both. It's a goofy looking division sign, sorry. So both of them's not allowed. Okay, well, we can do this. The Venn diagram helps us out quite a bit. So how many just have blonde hair? 6, right? See how it's not part of the bubble that's brown eyes? So just 6 of them. But I'm not done yet. I also want brown eyes, just people with brown eyes. And that's going to be 10. And then out of a total of 35 in the sample space. Remember, that or means I'm going to be adding. Okay? I want more to choose from. There's more people I favor when I'm choosing out of this survey. Okay? All right. So we get 16 out of 35, or 45.7%. Okay? Not too bad to interpret this. And in fact, you know, when you do surveys, sometimes it helps to have a nice visual to organize your data. And this is one way that you could do it. Okay? On the back, we have here, Amber is a college senior, and she's interviewing with Acme and Mills. Yeah, Acme and Mills. She's interviewing with those two companies. Okay, the probability of receiving an offer from Acme is 35%, and Mills is 48%. So receiving an offer from both is 15%. So not very likely both of them will give her the job offer. Okay, so filling this out, I have the actual percentages, the decimal versions, but still, I have the percentages of these guys. So I don't have numbers. My answer won't be a fraction. Okay, I'm not dealing with fractions. They already did the hard part for us. So we're just adding or subtracting numbers wherever we need to. So notice in this bubble, the 20 and 15, if I add those together, I get 35, which is what this is stating. The 15 and 33, when I add them together, I get 48. The 15's in the center, okay? And I don't know if you could see that. Let me zoom in just a little bit. Okay, just like that. And then on the outside is the odds of her not getting any offer whatsoever, right? Which would be 32%. If I add up all these numbers, it should be 100%. So notice it's a little bit different. Because this is giving us the probabilities ahead of time, we have to make sure it adds it to 100. Or, well, in this case, it'd be 1, right? When I convert it from 1 to a percent, it'd be 100. Okay? So that's interpreting this. And there's only one thing to figure out. Find the probability of receiving an offer from Acme or Mills. Not both. Okay? So let's figure that out. Probability Acme or Mills, not both. For some reason, she doesn't want both of them to give her a job offer. Maybe it's just too much pressure. And there's a lot of pressure when you interview for jobs. It really is. It's not a very easy process. And if it is for you, that's great. But speaking from experience, it's definitely can be petrifying. Okay. So how many, or not how many, what's the odds of just Acme choosing you? Okay. It would be what? Take a look at what they got here. What, 20%? It's so light. It's hard for me to see from this angle. And then what was the other one? For just Mills, it's 33%. We're going to add it. Okay? Now notice there's no fraction here because once again, it's already the percentages. They gave us the probability, so I'm just adding them. Okay? So put them together, we get 53%. So she has a 53% chance, which isn't terrible, that she'll receive a job offer from one of those. Just not both. Okay? Hopefully you can see the difference between giving you the numbers for it and giving you the probabilities for it. Okay? Last one. Now this one copied well. The top one I have to maybe redo someday. A survey of couples in a city is found with the following probabilities. The probability that the husband's employed is 85%. The probability that the wife is employed is 60%. The probability that they both are employed is 55%. I think that's becoming more popular nowadays, right? Well, I mean, not popular because there's a need for it. Cost of living in different areas is pretty rough. So both the husband and wife have to work. So here's the probabilities. Now, once again, when I add both of these in the husband category, I get 85%. When I add both of these in the wife category, I get 60. 55 is in the middle because it's the odds of them both happening. Okay? And then there's a 10% chance that neither one of them work. Okay? And once again, if I add these up, do I get 100% or 1 in this case? Yes. Okay. So, what is the probability that neither of them are employed? Kind of said it already, right? It's this number right on the outside. It's 10%. Okay, 10% chance that neither one of them are employed. And the last one, part B. The probability that the wife or husband, but not both. Okay? Just one of them is employed. Let's go back to the chart. So the odds that it's just the wife is what? 0.05. Okay? The odds that it's just the husband, 30%. Notice that 0.55, I'm not touching at all, because that's the odds of them both happening, right? I'm looking at just this bubble and just this bubble, not where they overlap. Okay? So we get what? 35%? 35% chance it's just one of them to finish it off. Alrighty. And and that's it. Okay. Could we do more with this? Absolutely. But just for like a geometry probability lesson, I think this is as far as we really need to go. So hopefully this helps. Look out for the homework. Other than that, that's it, guys. Okay, so enjoy your day. I will see you in the next lesson.